Last class we have discussed vertical stress at any point under rectangular loaded area by means of your, if it is either inside the rectangular area or outside the rectangular area or at one of the side of the rectangular area. So, by means of method of superpositions. So, there are different cases. Case 1 is it is at any point inside the rectangular area. Case 2 it is outside the rectangular area. Case 3, case 4 it will be one of the side of your rectangular area. It has been discussed. Then 3 examples I have solved. Example 1 is your L shaped building and pressure intensity is given, depth is given 5 meter, find it out increase in stress. Second one is your outside the loaded area at point P and find it out increase in stress. Third I have said again it is in between in the loaded area, it will be very easy, then you can find it out easily. So, let us start with one more example, equivalent point load method. Example 4, a rectangular foundation (3.0 meter by 1.5 meter) carries a uniform load of 40 kilonewton per meter square. Determine the vertical stress at point P, which is 3 meter below the ground surface. Use equivalent point load method. So, in this case what happened, this is what it is given, it is 3 meter by 1.5 meter. So, this will be 1 meter, 1 meter and 1 meter, this is 0.5, this is 0.5 meter, this is 0.5 meter, this is 0.5 meter. Now, equivalent point load means I divided into in such a way that this is 3 meter, I make it into equal. Here it is 1 meter, 1 meter and 1 meter. Here it is given 1.5 meter, I make it in equal 0.5, 0.5, 0.5. That means each size having 1 meter by 0.5 meter. So, it will be very easy to distribute. So, then load on each area will be load on each area will be 40 into 1.0 into 0.5. 40 is your load intensity kilonewton per meter square into area of each, that will be 20 kilonewton. So, that means each area having load intensity of point load, equivalent point load of 20 kilonewton. Let me set it as 1, 2, 3, then this is 4, 5, 6, 7, 8 and 9. I make it into in terms of 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the basic equation of your Bosniak's theory? Sigma z is equal to summation of 3q by 2 pi z square 1 by 1 plus r by z whole square and to the power 5 by 2. This is what is your equation. Now, in this equation each load intensity having q, it is known, z is given 3 meter, it is known. Now, r by z, what is the radial distance, you have to find it out. Now, for 1 and 4, this area and this area. So, r is equal to 1.5 whole square plus 0.25 whole square into root over, which is equal to 1.5 to 1. 1.5 whole square and 0.25 whole square for 1 and 4, then it will be 1 root over r is equal to how you get the r. If you look at how do you get the r, for this case r is your radial distance, this radial distance is your 1.5 plus 0.25, and for 2, 3, 5, 6, for 2, 3, 5, 6, 2, 3, 5, 6, if you look at here 2, 3, 5, 6, so it will be r is equal to 0.5 whole square so here it will be 0.5 whole square plus 0.25 whole square root over. This distance is your 0.5, this distance half of this will be 0.25. So, in this case it will be coming out to be 0.559. Then here first one r by z is equal to 0.507, here r by z is equal to 0.186. Similarly, for 8 and 9, look at here 8 and 9, your r will be, now this distance will be your 8 and 9, will be, if I am starting with this, it will be 0.75 and 0.5, r is equal to 0.75 whole square plus 0.5 whole square, then its root over, which is equal to your 0.901. I forgot to tell, this is the point P, with respect to this stress increase has to be found out. Now, if you look at here load on each area, that means if you look at here it is 20 kilonewton. For 1 and 4 I am joining here and I am joining here. For 1 and 4 this distance is 1 and this will be 0.5, hence 1.5 whole square, and this distance is your 0.25 whole square root over, this will be 1.52, r by z is equal to 0.507. If this is my point P, from here to here, these are all same, this out. For 8 and 9, if I put it 8 and 9, this is my point, distance from here to here, what is the radial distance? Now, if I take it, this will be 0.5 whole square and this will be 0.5 plus 0.25, this will be 0.75 whole square, this comes out to be 1.677. So, R by Z is equal to 0.30. Now come to 0.7, similarly 0.7, because what happened, 1, 4 are identical, then 2, 3, 5, 6 are identical equidistant from point P and 8, 9 are equidistant from point P. Similarly 0.7, draw a line here. For 0.7, R is equal to 1.5 whole square, R is equal to 1.5 whole square. That means, if I draw it here, this is your 0.5, this is your 0.25, 0.75, this is 1, this is 0.5. So, 1.5 whole square plus 0.75 whole square root over, it comes out to be 1.677. Then R by Z is coming about to be 0.559. This is how it has to be calculated. If you look at here, once again I am explaining, there is an area 3 meter by 1.5 meter is there. Load intensity in that area is your 40 kilonewton per meter square, and there is a point P has been given. You can do it earlier method the way I have said, you can take that point and make it small rectangle and at the edge you can find it out. But here it has been asked by means of equivalent point load, then we convert, you have to think how you are going to divide into equal number of smalls. So, here 3 meter equally divided 1 meter, 1 meter, 1 meter, here it is 1.5 meter equally divided 0.5 meter, 0.5 meter and 0.5 meter. So, load on each area will be 40 load intensity into 1.0 into 0.5, this out to be 20 kilonewton. Now, as per Boussinesq's equation, sigma z is equal to 3q by 2 pi z square 1 by 1 plus r by z whole square into 5 by 2. Now, what are the things? Q is known, z is known 3 meter, only r or r by z you have to find it out. Now, here if you look at 0.14 from point P, it is equidistance. So, for 1, 4 it has been calculated, 2, 3, 5, 6 again it is equidistance calculated, 8, 9 again it is equidistance calculated, 7 it has been calculated. Now, we just sum it up, the summation will be sigma z is equal to summation of 3q by 2 pi z square into 1 by 1 plus r by z whole square to the power your 5 by 2, and this comes out to be, if I write it, 3 into q is equal to 20, 2 pi into z square is equal to 3 whole square into, here it is 1 by 1 plus 0.507 whole square to the power 5 by 2, because there are 2 cases. So, then it will be 1 plus 1, it will be 2, here there are 4 cases, here it will be 4 by 1 plus 0.186 whole square to the power 5 by 2, here it will be 2 by 1 plus 0.3 whole square to the power 5 by 2, here it will be 1 by, because this is 7th, this is your 1 4, this case is your 1 and 4, this is your 2 3 5 6, this is your 2 number, 3 number, 5 and 6, this is your 8 and 9, and this is your 7. So, it will be 1 by 1 plus 0.559 whole square to the power 5 by 2. So, then it comes out to be 1.061 into 1.129 plus 3.674 plus 1.612 plus 0.507. This comes out to be 7.34 kilonewton per meter square. So, this is how you can solve same problem. Suppose this is the problem, as I have said, explained here by equivalent point load. Now, if this is a point P located at a distance 1 meter and here at a distance 0.5 meter, if this is your 2 meter and this is your 1 meter. So, I can do it by making into in this way also this point P. So, it is a summation. What happened? This is your rectangular area, here it is at the corner, again this is your rectangular area, here it is at the corner, again this is your rectangular area, here it is at the corner, again this is your rectangular area, here it is at the corner. So, you can solve also this way. Equivalent point load, what I did, I have made it into 3 parts, here it is 1 meter, 1 meter, I distribute into here, then so point P 1, 2, this is my radial distance I calculate for each cases at the centroid calculated radial distance, and from there increase in stress has been calculated. So, this comes out to be 7.34 kilonewton per meter square. I completed most of the examples. So, let me start with this Newmark's influence chart or influence sheet, that will be interesting. Newmark's influence chart. So, if you look at here Newmark influence chart, it's vertically Newmark has been proposed. What happened earlier? There are cases where increase in stress below a point load, increase in stress below a strip load, increase in stress below a line load, increase in stress at the corner of the rectangular loaded area, increase in stress at the center of the circular loaded area. These are the cases we have discussed. However, for Newmark's chart, if you look at for Newmark's influence chart, Newmark's has been given to find it out vertical stress under a uniformly loaded area of other shapes. What does it mean other shapes? It is not a strip footing, it is not a circular loaded area, it is not a rectangular loaded area, not a line load. If I say this is my things, find it out increase in stress, it is none of these shapes. So, Newmark's has been given, and in this case the concept has been taken into carry forward like this. If I take it a circle, right, then here divide into number of equal parts. Let us say this is my R1, this is my R1, and this part will be, let us say this is my R1 So, it is based on your vertical stress below a circular loaded area. It is the concept is based on the vertical stress below the center of circular area, below the center of circular area. If R1 is the radius of the first circle, let us say this is the first circle, R1 is radius of first circle, then it divided into 20 equal sectors, 20 equal sectors. So, vertical stress at a point P at a depth Z below the center of the loaded area due to load on one sector, any one of the sector. If I say this is my only one sector, then it should be delta sigma Z should be 1/20th of q into 1 minus 1 by 1 plus R1 by Z whole square three by 2. If you apply, take a concentric circle divided into 20 equal parts, then because it is a circular loaded area, at the center here, let us say at the center here O, below the ground surface this is my point P, then for circular loaded area this is the increase in stress Q into this. If I divide into 20 parts, if I taken only one sector, it should be Q by 20. Let us say vertical stress is given by arbitrary fixed value of say arbitrary fixed values, let us say it is 0.005 q here, and from there if I put it, delta sigma Z is equal to 0.005 q and here 1 by 20 q into 1 by 1 plus R1 by Z whole square to the power 3 by 2, then it comes out to be R1 by Z is equal to 0.270. So, every 1/10th center of the circle with radius R1, what does it mean? Every 1/10th, 1/20th, that means because you have divided into 20 parts, every parts will be equal to your R1 will be 0.270 Z, R1 will be 0.270 Z. Now, if this small area exists 0.55 P, so similarly consider another circle R2. So, this will be R2 from here to here. Then what will happen? If I take the same concept, so this and this two part will be 2 into 0.005 q, which is equal to 1/20th of q into 1 minus 1 by 1 plus R1 by Z whole square to the power 3 by 2, right. Then what will happen? It will be R2 by Z, which is equal to 0.4 Z. So, that means now if I increase, then if I go for third, fourth like this. So, what will happen? Suppose here it is circle, here it is here it is, here it is, So, this is point O and this is the value of the P. Now, if you do it, what will happen? So, if I continue like this, so this is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth and 9.6. So, what will happen? It is increasing like third to ninth circle, it is increasing 0.5 to Z, 0.64 Z like this, and R10 will be tends to infinity. That means, once 10th circle I am drawing, it is tending towards infinity, it is tending towards the infinity. So, the procedure I'll elaborate how the procedure has been done. So, consider here it is like this, take a scale, this is your AB, A and B, AB is equal to your depth. So, what is your procedure? Procedure will be plan of the loaded area is drawn on a tracing paper, whatever this shape. If this is the plan of the loaded area, plan of the loaded area drawn on tracing paper. So, the scale has to be drawn in such a way that length AB is equal to depth. Depth means at what depth you are supposed to get it. Then plan is placed over numeric chart. So, you prepare the numeric chart up to 9.6 circle, not 10 circle. 10 circle the value is going about to be infinity. So, plan is placed over the chart means numeric chart, such that point P at which pressure is required, such that point P at which pressure is required consider with the center of the chart. Suppose here is the point P, you prepare in the tracing paper, then plan is placed here in such a way that the point P will be your center of the chart, it is merged at point O. Then count this plan area, how many number of circles it is covering, count. Then from there you can find it out, sigma Z is equal to I into N into Q, because pressure intensity every point you can know. So, only N is equal to number of small area unit, N is equal to number of small area unit. So, in this case I is your influence coefficient or influence factor, influence coefficient is your in this case 0.005. So, like this you can find it out any shape by numeric chart, other than we have discussed about the point load, circular loaded, line load, then rectangular loaded, all cases we have covered. Other than these regular shapes, if any other shape is there, you can find it out what is the stress at a point Z below the ground surface. I will stop it here. Thank you.